Good evening, everyone. Thank you, Hassan, first of all, for taking the initiative to organize this. And once I found the page, well, I just volunteered because I'm fascinated by the topic. I think that it's got multiple applications, not just in construction, but also throughout the entire life cycle. For myself, I always refer to the AECO sector, the ousted, the most forgotten part, which is the operations of that building or that asset. So I think that actually machine learning and other facets of digitization will affect far beyond just the design and construction phases. In fact, where do we get a lot more data? It's actually when the building is in operations and through the monitoring sensors embedded within those assets. Okay, so my short talk is going to cover 7 areas of digitization. I focus on 7 because it's an easy number to remember. It's certainly not the only 7 out there. And I think that for most of us, we may have heard some of these digital technologies, but I'll give you some examples of how they're being applied in research, first and foremost, how we're applying it on our research initiatives that we're working on, and some of the tools and technologies that are being developed as a result of those research initiatives. So the company I work for, and myself and Peter here, who's volunteered to film the content so that you guys can have access to it afterwards, we work for Exergy. It's a small company. We focus on research and development work. And a lot of the research that we do is in sustainable processes as well as green buildings technologies and also digitization of the construction and design sector. So I've transitioned from former work in academia and research now into doing some research development, something that's between industry and academia, largely with Horizon 2020 initiatives, so through the EU Commission. And right now, as a result, we're developing new technologies in the domain of some of these 7 digital dimensions. So just to briefly go over, I'll give you a little introduction to the background. What are the 7 digital dimensions as I see it from my research in the past? And some of the initiatives we're working on, such as BIMERR, which is a big research project only recently started, €4.2 million initiative on just digitizing the European existing building stock with BIM. The second one is Stacker, which is an app, a mobile app that we're developing, which is for installation purposes, utilizing BIM and of course some immersive technologies such as augmented reality. And then I'll give some other exemplars of what we've seen in the research literature, from PhD graduates to professors to research laboratories that are trying to basically apply machine learning in the context of construction. Okay, so smart cities is probably a very known or trendy term that we've all come across, but essentially what's integral to smart cities is the integration of our physical systems, but I believe also the communities and the people that inhabit and live in those cities themselves. And one of the things that's obviously becoming inseparable now is the digitization of majority of our activities. And we're becoming inextricably linked with our devices. And although we do like to say that the construction industry is far behind in digitization, the reality is that actually, if we look at majority of our workforce, almost all of us has a smart device, a phone. And this connectivity is now starting to proliferate, and we're starting to see a lot more tools that are becoming accessible to the everyday person within the workforce, especially in construction. So smart cities is ideally the connectivity, the cyber-physical connectivity between the community and the system themselves. And of course, this is supposed to be one of the solutions to the mass urbanization and population growth. How do we manage mass urbanization, this predicted world population? One of the solutions, or one of the panaceas, so to speak, is the proliferation of cyber-physical connectivity and being able to manage such complex systems as the population is set to grow. And BIM, I will touch upon it because it's important and integral to us. It's the most fastest developing form of digitization that we as AECO professionals know of. UK is in a good position here. We're seen as the vanguard. Most of the EU member states are now replicating what the UK BIM mandate has done. And so that is set to also be the stepping stone for a lot of the other digital tools that are being introduced to us. And with that in mind, Construction 4.0 is our surrogate of the Industry 4.0 movement. That is the integration of cyber-physical systems everywhere within the design stages, through to bidding, onto the construction site, and then finally handover and operations of the building. So Construction 4.0 is just our surrogate of the movement of data-driven decision-making. And there are a lot of digital tools and technologies that fall as part of that, some of which Hassan already discussed, such as computer vision, or the use of Internet of Things, which is analytics from sensor-based data. So a lot of it is proliferating the tools that we're currently using. So for me, the 7 digital dimensions that I will cover only partially some of them here because I'm limited in time, but certainly cloud computing is very important. Big data analytics, or the Internet of Things, blockchain, 3D printing, machine learning, and robotics. And hybrid technologies is just an amalgamation, or the integration of any of these aforementioned technologies. Probably I'm missing out on a lot of others here as well, but for brevity, we'll look at some of these. So hybrid technologies is computer vision, for instance. Computer vision is the combination of analysis of our still images, and it originated in manufacturing. So it's actually originally called machine vision, and it's just used for quality assessment of our products that go through the line. Originally used image technology and also laser scanning technology to validate the quality of products being manufactured. But as you know, the construction sector is always trying to emulate the manufacturing sector. So we're trying to do the same now. But we can't keep laser scanning everything on site, so we're trying to rely on just images. And this is what Hassan was giving examples of, so identifying health and safety features or hazardous behavior on construction sites. So that's just one example of hybrid technologies. Blockchain is certainly another fascinating aspect. For instance, if we separate it from our pre-existing notion of Bitcoin, then the underlying technology of blockchain can be certainly applied in automatic procurements and contracts, signatures and signing and etc. But I'm not an expert in that. Peter is actually a really good expert in blockchain and fintech. So we work on a lot of research projects and initiatives, largely through the European Commission. These are just some of them. It's actually more than this. We've got over 25 projects, some of which relate to sustainable processes, others that focus more on innovative materials, for instance, green facade panels using geopolymers. So it's a mix of an arranged areas of engineering in the physical built environment sector, and also in the valorization or making use of existing materials and resources. So BIMERR is one of the more recent initiatives, which is to digitize the existing stock of buildings across Europe. And BIMERR is a big initiative. We have a lot of partners, largely software companies, and also construction companies such as Ferrovial from Spain. And in essence, the idea is to develop multiple tools, some of which will assist in the digitization of our existing buildings and also assist in decision making for renovation of our old building stock. It's supposed to make it more accessible for the everyday person again. And of course, BIM is integral here because BIM is the data that we're using for some of that decision making. So some of the tools, and they include software and hardware, is smart glasses. For instance, we'll be demoing the use of smart glasses on 2 sites, one within Poland, one within Spain. And that is going to then use, obviously, the BIM data to overlay it in the construction workers' field of view. And then the basic augmented reality applications that will be more accessible to the residents. But we're using a lot of different types of data. At the heart of the project itself is, first of all, let's try and overcome this interoperability issue. That's partly why the consortium consists of so many computer scientists, because interoperability is inseparable when we talk about BIM. That's been a critical problem with data sharing and acquiring lots of data. Our tools and systems don't talk to one another. So that is the first problem we're trying to tackle. And then it is to cascade into some of these other tools, such as scan to BIM tools. So that is doing a laser scan of our existing building, converting the point cloud into automatically recognizable objects that can be converted into 3D objects in a BIM, essentially. Residential behavioral profiling tools, so use of energy, for instance, and making alternative suggestions to the residents of those homes. So that's going to involve a lot of sensor-based technologies. Most of this we're trying to gear towards mobile applications, smartphones primarily, and also process and workflow modeling tools for the construction managers themselves, as well as the renovation decision support tool for the architects, those that are in charge of the design initially, because they have a quintessentially important piece of, let's say, an important piece of the puzzle in the decision making of how we're going to specify the types of materials that are appropriate, A, for that type of building, B, for its climatic conditions, and C, also for the residents that need assistance in how they should be using that building and its space. So there's a lot of tools being developed from a single project, and that's why it's a 4-year project. Stacker is another tool that we're working on, and it's from a project called Size and Precast. The project is actually coming to an end now, and it consists of the development of prefabricated concrete panels for seismic regions. And one of the problems that they needed addressing is how to assist them in remote installation on site, because usually they tend to have to install these types of panels in very far remote locations like Mexico, Uruguay. So one of the areas of our focus is to develop a mobile tool to assist them in the visualization, rapid data retrieval, try and hopefully link that with better time management on site. But if we're talking about prefabrication, they're already cutting out a lot of time, so they're doing pretty well there. And also to assist the construction workers on site with installation of those panels. So it's a mobile application and also a web-based application. But as I say, it's still ongoing and the project will finish around December. But as with a lot of research projects, as you finish, the products you develop are not yet commercially ready. So we have different levels of technology readiness levels that range from 1 to 9. We expect it to be around 7. So not yet ready to be sold, but we're in the development where we need feedback. We need people to assist us and to guide us in that process. And largely it consists of the integration of AR and VR into an Android device to assist them for installation on site with the prefab components. So not a lot of machine learning here yet, but we feel like that is the next stage of development. We also extend an invitation to all of you. If you want to scan the QR code and register your interest, then because we will be hosting a full-day workshop in Coventry University at the Simulation Center in November to get industry feedback on how to make the tool more applicable to the everyday construction worker for installation purposes. So if you're interested in attending this one-day event, then just scan the code and you should be redirected to a form. No?
We should reply. So I think we need to add in all the emails first.
Anyone else? Well, worst case worst, we can go analog and I can just write down.
Well, we will send this presentation also.
Yeah, we will.
You will have access to it.
Other exemplars from research. So if we talk about those 7 dimensions, one that was on there is certainly big data analytics and the Internet of Things. So this is past research that I conducted together with colleagues from Pakistan, Riyadh, and what we did was we integrated wireless sensor network modes with building information data, and she did also some analytics of that sensor-based data. And largely this was to capture some very basic, let's say, sensing of the spaces, which was temperature and humidity. And based on the temperature and humidity ratings, we then mapped it out with what's safe in confined spaces in terms of temperature and humidity. And we were able to analyze how safe those spaces are. So to begin to predict essentially if the temperature is going to be increasing here, then how likely is it going to become hazardous for the construction worker within that confined space. So that's one example of application. The next stage was then when we connected that with the physical, so the physical location of the sensor modes with the actual room in the BIM models in order to visualize or self-update the information about that room or space within the BIM model. So it's just an early prototype concept, but essentially we're linking sensor-based data, we're visualizing it, and we're feeding back that information into that specific room in the BIM representation. You know, there's a lot of talk about digital twins, but if you want to achieve the digital twin movement, it's got to be linked with actual sensor-based data continuously from that physical location. So that's certainly one area to think about. Another hybrid dimension is the combination of machine learning and sensors. So this particular work was done with Hong Kong Polytechnic University, and it was to monitor the spinal position of the construction worker when lifting rebar. And there are identified safer ways of lifting that rebar, right? And what the analysis was doing was measuring the position of the spine and classifying it, whether it was the safe way to lift or not. So it was identifying, classifying different ways of lifting that rebar, and then also notifying the construction worker whether it's safe. And the notification, which was the second part of this same research, was via smart wearable watches, which these days you can buy very cheap ones from China for about 20 pounds. So it's accessible technology that can be tested on site. Another one this one I haven't been involved in, sorry. It's again computer vision technologies. I refer to it as machine vision, and it's again trying to analyze still images of work on site and classifying that type of work. And a lot of this work in computer vision is really led by Huaishang University of Science and Technology. Now they have a really big BIM laboratory where they're specifically working on how to actually apply computer vision in practical cases on the construction site. And they've been doing really great in this domain. And so I would say if you're looking for examples of computer vision in construction, I would definitely look at the work of Han Bin Lao and his team at HUST. So those were just very small snippets and exemplars of some of the dimensions. I would now ask you as the audience to consider and explore if you feel that some of these dimensions are applicable to your everyday work, or if you feel that there's potential in applying some of the dimensions to the problems that you currently face. And then we can use that as momentum in our upcoming meetings to try and identify how we could potentially tackle some of those issues with real data. Because that, none of this would be possible if we didn't have data. And unfortunately, in machine learning, the more we have, the better it is. That's why a lot of this work is using sensor-based data, because it's continuous influx of data that can be analyzed. So that is all from me. Thank you for your time. Does anybody have questions about any of the research initiatives? No? Okay. All right. Thank you.